So for my final project, I analyzed the total cancer counts in the United States based on sex, ethnicity, and geographical location. An abstraction is a technique used by computer scientists to reduce the complexity of real-world systems by removing extraneous information that can better be modeled on a computer. So for this study, I abstracted cancer reports into a list of cancer counts based on sex, whether that's male or female, race, whether that's white, black, or Hispanic, and geographical location, whether that be the North, New York, versus the South, Texas. These reports have a number of different properties that correspond to the project that can help us better filter our data in order to acquire an answer based off of the information in the reports. So data is a dictionary that contains float, integer, and string properties representing the various counts of cancer, crude rates, event type, population, race, and sex. This is needed in order to filter all of the data in order to see the cancer counts based on the variables that we want to see, such as say, sex or race. Area is a string property that represents the location of individuals when diagnosed with cancer. This is needed to see and analyze the total number of people in the area, whether it be the north or the south, east or the west, in order to determine if this affects the total amount of cancer count data. Race is a string property that represents the ethnic group of the individual diagnosed with cancer. We need this in order to select for either white, black, or Hispanic individuals to see if this could have an impact on the cancer counts and see if this can answer the questions being asked. Sex is a string property that represents the sex of the individual diagnosed with cancer. This is needed to filter data selecting to see if sex, female or male, will play a role in cancer diagnosis counts in comparison to that of gender or race and the area that they are in. So we face a few limitations when we want to analyze this data in order to come up with an answer to these questions. And one of the largest issues that the question presents is the complexity behind the data needed to give a proper answer. When there's a question regarding cancer count totals of different demographics, it's important to analyze the population of each demographic in order to understand how much of that demographic actually makes up the total population. Like, for instance, this study only uses one northern state and one southern state. Therefore, the conclusion may not be sufficient given the data. We might want to analyze several states in order to see a better conclusion. The study also uses comparisons between 3 ethnic groups, which all make up a different total percentage of the population of the United States. Thus, this needs to be considered when we want to actually come up with a conclusion when analyzing the data. This is also something to consider when comparing male versus female. We want to look up the actual total percent makeup of males in the United States and total percent makeup of females in the United States. So based off of the complexity, we can also have an issue of completeness. There may not be enough data to draw a good conclusion. However, there most likely is not enough data to draw a true meaningful conclusion given the state of total cancer count totals in the North versus the South, the black versus the white versus Hispanic, or the male versus female. So the image on the right demonstrates the abstracted data that we can use to actually answer our question and how we can filter our data in order to select for the variables that we can compare in order to see if there is any correlation between cancer counts and the different variables such as race, sex, or area. The data key is the dictionary which is associated with the count, which represents the total amount of cancer patients. The count is based on other keys such as area, race, or sex, which filter the data depending on those 3 variables, whether or not the area would be state in the United States, race would be black, white, or Hispanic, or all races, and sex would be male or female. The area key is associated with, which is a string value, is associated with location in which the cancer counts are recorded. In this case, would be in the states of the United States. So this actually brings me to my questions. In 2011, PubMed released a study claiming that men have higher cancer death rates than that of women. Our research suggests that the main factor driving greater frequency of cancer deaths in men is the greater frequency of cancer diagnosis, rather than poorer survival once the cancer occurs, says study researcher Michael B. Cook of the National Cancer Institute. The study is published in Cancer Epidemiology, Biomarkers, and Prevention. The article states that if investigators can identify the causes of these gender differences in cancer incidence, then we can take preventative actions to reduce the cancer burden in both men and women. This draws in a few questions. What are the differences in cancer counts for men and women for cancer in the United States? What are the differences in cancer counts depending on area in the United States, North versus South in the instance for this study? And what are the differences in cancer counts between race, white versus black versus Hispanic? So using Python, we can actually generate visualizations that can help us draw a better conclusion based off of the data, which is all packed together in the list of reports that we're given. So for the first visualization, we are asking what are the differences in cancer counts for men versus women in the United States. And based on the visualization to the right, we can see that males have a higher average number of patients, which looks to be about 17,800 patients, versus the average number of female patients, which is about 17,200. So based off of the data and the visualization, we can conclude that males in the United States are more susceptible to getting cancer than women. It's important to note that it is not a considerable difference, however, it is a difference nonetheless. This difference is more notable, however, when considering that females make up 50.8% of the US population and males make up 49.2% of the population. And since males have more cancer counts than women as a total average when looking at the visualization, this just further helps prove that men are more susceptible to getting cancer than women, which was initially stated within the study. So for our second visualization, we're asking what are the differences in cancer counts depending on race, whether that be Hispanic, Black, or white. So our visualization shows that the white race has a higher average number of cancer patients, about 40,000, opposed to Black, 5,000, and Hispanic, 5,000. So based off of the data and the visualization, we can conclude that white individuals in the United States are more susceptible to getting cancer than Black or Hispanic individuals. It is important to note that white individuals make up 61.2% of the country, while Black make up 12.7% and Hispanic make up about 17.8% of the country. When considering these percentages based on a 325 million person population, however, white individuals are still contracting more forms of cancer than the other demographics considered. So for our third visualization, we're asking what are the differences in cancer counts depending on area of the United States, north versus south. Visualization shows no real difference between cancer patients in Texas, 30,000, versus New York, 30,100. So based off of this data and the visualization, we can conclude that geographical location does not play a significant role in total amount of cancer counts. Both New York and Texas have similar population trends and numbers, which just helps further demonstrate that the state location of the individual will play no significant role when diagnosing cancer. So we want to actually consider why does this matter? So we want to look at the stakeholders, the impacts, and the conflicts amongst the stakeholders. So for the stakeholders, we need to consider pharmaceutical companies that are actually developing cancer medications, individuals with cancer who need cancer treatment, insurance companies covering these individuals with cancer, and people who could necessarily be more at risk for a cancer depending on their demographic. The impacts: the study could result in particular individuals getting checked for certain cancers because they realize they're at a higher risk than other races or sexes, such as white males with colon cancer, since males are more likely to be diagnosed with cancer than women, and white males are more likely to be diagnosed with cancer than a Black man or a Hispanic man. A white male might want to consider getting checked more often than other individuals because they are more at risk to getting cancer. This could actually result in less cancer deaths as a whole, with more diagnosis occurring as individuals can highlight these risks more easily because of the data provided by the study. They can identify that they are more at risk. Conflicts amongst these stakeholders: researchers and pharmaceutical companies could start to target particular demographics of people because of the higher risk that is associated with them. Insurance companies could charge white men more coverage because they are more susceptible to getting cancer, charge less for Hispanics or charge less for Blacks, which this could be more difficult for some demographics to get insurance, or more easily for more demographics to get insurance. Demographics who feel more at risk could call for more treatments on cancers that focus on their group, such as skin cancer for African Americans, which has been a notable issue for the African American community. I have neither given nor received unauthorized assistance on this assignment.